All right, on section 4 of chapter 9, day 1, we're going to look at sine and cosine curves. Okay, what a sine and what a cosine curve looks like. And some of you may or may not have seen something like this before. Have any of you ever seen sine waves, or like sound waves, I mean? Like on a reader, okay, where it looks like a wave? Okay, sine and cosine curves are those waves. They come in here like this, and that's what they are going to look like. Okay? What we're going to do today is we're going to look at how to calculate some of that stuff, and then also how to draw them. Okay, so you're going to figure out how to draw them based on some of the things that we said. Okay. Okay? So, first of all, first in format with them, here's the type of format that you're going to see. You're going to see the sine of x, or y equals the cosine of x. Okay? That's what's going to happen for those. As far as the domain goes, if they ever ask you for what's the domain, every single one of them or both of them are all real numbers. These continue to go on forever from left to right. Okay, so there's no break in the action. It just continues to keep going. Okay. The range on the generic one ends up going from -1 to 1. Okay, what's the range refer to again? Do you guys remember? If the domain is x's, or the left to right, what's the range? The y's. Right, from the bottom to the top. Now, I put that in interval notation. That's the same thing as me saying it like this. -1 is less than or equal to y, which is less than or equal to 1. That just means that it has a high point of 1 and a low point of 1. So everything's in between from -1 to 1. Unless you stretch it, which is what we're going to work on today too. Okay. The next thing we're going to talk about is the amplitude. Okay, or amp. And what they refer to the amp as a function of 1/2 the difference of the maximum value and the minimum value. Okay, that's what the amp is, and I'm going to show you how to find that. The amp actually for a formula is whatever the absolute value of A is. And I will show that to you in a second. I'll put that on the graph so it's easier to see what I mean by amp there. The next thing that we're going to refer to is the period. Okay, the period is nothing more than a cycle. Okay, so that's when it, if you notice when they started to do it, and I know Hunter was doing this with his arm. Okay, if you've ever been outside, like if you've ever been driving in a car and you have your window rolled down and you, like when you were a kid and did this, you were making sine and cosine curves. Okay, it's when it repeats. That's what it is. That's what your period is when your cycle repeats. Okay? And as far as the formula for this one goes, the period is 2 pi over the absolute value of b. And I'll explain where a and b are in just a second, okay? And as far as the different things for that, that's as far as where they're going to be. Now, in order to put a and b in there, a is going to be in front of the sine or in front of the cosine. Ooh, that's horrible. Okay, that's where the a is going to be located at. And the b is going to be located in front of the x. If there's not a number in that position, what number should it be? 1. Right. So that's all the different pieces with it. This is what we're going to be identifying in order to graph things. You are going to be dealing with a lot of cutting things in half when you're dealing with your period. Okay, or finding out when it crosses and when it doesn't cross. Okay? But these are some of the characteristics of it. If it asks you for the domain for both of them are all real numbers. If it asks you for the range, it's -1 to 1 unless we change it by stretching, which is what the amp will do. The amp, I read you the official definition of what amp is, but amp is really the height from the x-axis to the top. Okay? So whatever that height is, so if we have a range of 1 and it goes up 1 and then down 1, okay, the official thing, it's going 2 units, but realistically the amp is just 1 because it's from the x-axis to the high or x-axis to the low. Okay? So here's what it's going to look like for you. It's going to say g of x equals 4 sine of x. Okay? So what they're going to want you to do for this is they're going to want you to identify the amp, identify the period, then sketch the graph. So what number is in the amp position? 4. So the amp is equal to the absolute value of 4, which is what? What's the absolute value of 4? 4. The distance from 4 to 0 is 4. Now, to identify the period, we were 2 pi over the absolute value of b. What number is in the b position? 1. So we are 2 pi over 1, which is just 2 pi. Okay? Everybody okay with that so far? All right, now comes the graphing part. When I'm graphing this, what I do is I'm going to make a coordinate plane, but it's going to be different than normal. I'm not going to make one perfectly in the middle like that. I'm going to make it go longer here and then cut that right down the middle, and I'm going to elongate that to the right. There's a reason. Because these aren't graphs like a circle or a triangle on it. These are curves like a snake. Okay? So, as far as the amp goes, the amp was the distance from the x-axis to the top, or the x-axis to the bottom. So when you told me that amp was 4, that means I'm going to go up 1, 2, 3, 4, and I'm going to make a dashed line. And then I'm also going to go down 4, 1, 2, 3, 4, and make a dashed line. Now, the reason why I'm making the dashed lines, you guys, is so that I know when to stop. So I'm going to go up, hit the dashed line, and then come back down, hit the dashed line. I can't go all the way through that. The dashed line is like the stopping point, like a fence. Does that make sense so far? Everybody okay with that? Now, your period. What's the length of the period? 2 pi. So, when we put this out here, 2 pi, don't bother me. So when I put 2 pi out there, now I want to cut that into fourths. So here's what you have to do for me. What's half of 2 pi? Pi. So when I put pi on there, if 2 pi was to here, about half of that is 1 pi. So I'm going to try to cut things in half now. What's half of 1? 0.5, 1/2, pi over 2. Since I had pi in there, I'm going to use pi over 2. And I'm trying to locate it as close to I can in between, halfway in between. Am I using a ruler to measure that out? No. Could I? Sure, but I don't need to. Try to make it go as close to halfway as possible. Everybody okay with that? Now, the only other one that I need to know is what's halfway between 1 and 2? 1.5 pi, or in fraction form, it's 3 pi over 2. Those are the critical points when it refers to graphing a sine curve or cosine curve. Now, one thing I hope you guys are going to notice when I draw all these, every single one of these shapes are going to look very similar. All the stuff's going to be there. What's going to matter is when you label. Okay? When I label it, how far apart are they? Now, realistically, I probably could have went a little bit further apart so I could show it, but really, it doesn't matter. Now, here's where the sine curve and cosine curve differ. The sine curve starts at the origin. So I am going to start this sine curve right here at the origin. Okay? And now, because it's a positive, which we haven't talked about the negative, and we won't today, I'm going to go up and hit that amp at pi over 2. The first one that you found when you're going from left to right, that's the first number on the trail. Now what do you think I'm going to do for the next part? I'm going to go down. I'm actually going to strike through the pi, and I'm going to go down to when? The 3 pi over 2. And then I'm going to come back up and hit it at what? 2 pi. Now, here's another important part. I'm not going to go any further, but all I'm going to do is make arrows on the end of this. Why am I making arrows on the ends of my curve? So that I know that it keeps going. Now, this is the part that a lot of people struggle with, is the graph. You guys do beautiful jobs getting the numbers. It's the graph that you guys struggle with. It starts at the origin, comes up to the first number that you have, goes through here. Does not bounce here. That's what a lot of people think, is that it bounces at the halfway point. At the half of the period, it should strike through it. Hit the 3/4 of the way, and then go the rest to the other one. Then, if I did 2 periods worth, I would just continue that curve. That's what a sine curve looks like. That's what you're going to be doing today. Now, on the alternative, cosine curve. One half cosine 2 pi. To finding the amp and the period for cosine and sine, it's the same formula. So, what number is in the A? 1/2. So the amp, what's the absolute value of a half? A half, good. As far as finding your period, it's 2 pi over, what number was in the B? 2. And what cancels? The 2's, so what are you left with? Pi. I am going to set this one up identical to the sine curve. They are set up the same way. The difference is where you start. That's the difference. So, I'm making my y axis, my x-axis. Now, here's what I wouldn't do. Remember the last one I went out there at 2 pi, and then now this one, the period's pi? Try not to, give yourself some room, because you still got to make all those halfway marks or the 4th marks. Okay, so give yourself some room. It's all in the labeling as far as how it really looks. So if I put pi way out here, is that wrong? No. It's just a matter of whether or not I want to make myself or have enough room. So, what's half of pi? Pi over 2 or 1/2 pi, 0.5 pi, I'll take all of them. Doesn't matter to me. What's half of half? 0.25, 1/4, so pi over 4. What's halfway between a half and 1? 0.75, which is also 3/4, right? You are going to get really good at cutting things into fourths with these. That's what you have to do. Is everybody okay with how I got those numbers? I took the period, I cut it in half. Then I took that number and cut it in half. Now, realistically, here's another thing that I showed people in the past. If you took 1/4 plus 1/2, you get 3/4. Okay? Just so that you are aware of that. If you take this one plus this one, you get this one. Alright? Every time. Now, how high up do I need to go? Okay, so if I put this out here as 1, half is halfway, right? -1, so halfway. Here's the difference in how they start. The sine curve started at the what? At the origin. The cosine curve starts at the amp. So I'm going to start this up here. That's where it's starting. Okay? Now, just like the sine curve, now I'm going to make the snake go through there. So if it starts up there, it's going to come strike through the fourth. Then what's it going to do at the half point? It's going to down to the half, and then what? Come up through the 3/4 and finish at the pi. And I put my arrows. Now when I make one cycle or one period's worth of the cosine curve will look a lot like a U. You know what I mean by kind of a nice smooth U? Does that make sense? Okay. Your cosine curves should look kind of like a U shape when you get done, or a V shape if you want to look at it that way. Not cornered, not sharp turned, but nice smooth curve. Okay. What do you think? Again, here's where you guys might mess this up. A lot of people do this. They start at the amp, they hit the x-axis, and then they bounce it back up there. These things have to go through. They have to go from amp to amp. Okay, and that's where a lot of people mess that up, is that they don't go all the way from amp to amp. Okay? What do you think? As far as the first assignment today, the first part of it, this is all that's going to happen. This is all you're looking at. Okay? So if you go to page 491. On 5 through 8, it says, determine whether the graph represents a periodic function. If so, identify the period. Okay? Does it look, and what they mean by periodic function, they are asking you, does it have a cycle? Does it look the same? Does it have a spot where this all of a sudden would mirror this? That's what it's asking you to do. It's yes or no. Then on 9 through 12, it says identify the amp and the period of the graph. So if I look at number 9, how high up does that go? From the x-axis to the top. How far up does 9 go? 1? Right? That's the amp. Good. Okay. Then as far as the period goes, they have markings on this picture that have this thing going up here, coming down, and then coming back up, and halfway there is 2 pi. And then they have other marks in here. Okay? They're giving you that for a reason. Okay? So as far as finding out for number 9, the rest of it, if that's 1, 2 is 2 pi, 4 pi, 6 pi. So when does it repeat itself? How long is the cycle? Not 2 pi, because it doesn't get to that height until it gets out here to 8. So when does it start this way and hit at the end that way? How long? 6 pi. Done. Then on 13 through 20, identify the amp and the period of the function, then graph the function, and describe the graph of G as a transformation of the graph of its parent. Okay, and this is part that I almost forgot to do. Okay, so as far as that goes, when it looks like this, or cosine, doesn't matter. The A is a vertical stretch or shrink, and the B is horizontal stretch or shrink. Now, I'm not going to go through that too much because how many times have we done horizontal stretch or shrink, vertical stretch or shrink? Too many times to even know. If I said vertical stretch, what number should vertical stretch be? Above 1. What numbers are vertical shrinks? They're between 0 and 1. Horizontal stretches are between 0 and 1. Horizontal shrinks are above 1. Those are not anything different. Okay, those are the same thing that we've been dealing with since the first chapter. Everything about that's the same. Just there's the location. Okay, do you want me to do any more? No? You guys good? Okay. All right, so on page 491, we're 6 to 18 evens.